using double angle and half angle identities. So we've looked at ways to maybe prove these, and now we're going to see how that they're used. So we have sine of 2x is equal to 2 times the sine of x times the cosine of x. We also have cosine of 2x equals cosine squared of x minus sine squared of x. And we have a few others we can manipulate to also give us cosine of 2x. I'm just going to use this one identity for cosine of 2x. And then our half angle formulas, sine of x over 2, so that's cutting that angle in half. That's equal to plus or minus. The plus or minus are important, so we'll talk about those a little bit later. We have to look at where we're looking at the angle to figure out if it's plus or minus. And that's the square root of 1 minus cosine of x, so that same angle not cut in half, over 2. Cosine of x over 2, very similar to our sine of x over 2, is equal to plus or minus the square root of 1 plus cosine of x, so that's the original angle, over 2. So now let's take a look at how these identities work. So let's say we know that cosine of x is 1/5, and we know x is in quadrant 4. So this quadrant 4 is going to tell us the sign of a few things. So we want to be careful with our sign, knowing that the cosine is in quadrant 4, because cosine has several places where it can be 1/5, but we know it's in quadrant 4. So when we draw this cosine, we're going to draw it in quadrant 4. And when we draw the cosine right here, when we're looking at our reference triangle here, we want to draw it with respect to the x-axis always. So we're never going to be talking about this angle right here. We want to draw it with respect to the x-axis because that's how we measure our angles. So if we want to find sine of 2x, so double this angle, and the cosine of 2x, we can use those identities. So first we need to find, if we want to find sine of 2x, we have to have 2 times the sine of x times the cosine of x. Well, we know cosine of x, but we don't know sine of x. And so we're going to use our triangle to find sine of x. So first we draw the triangle. We know that cosine is equal to the adjacent over the hypotenuse. So my 1 is my adjacent to this angle x over the hypotenuse, which is 5. So my 1 over the hypotenuse. And then I can use the Pythagorean theorem to solve for this side length. And the reason I want this side length is because I need to find the sine, and the sine is the opposite over the hypotenuse. So I have 1 squared plus b squared, I'm calling this side length b squared, equals 5 squared. And you can see I've already solved for it, but this is how I did that. And then I square, this is 25, and this is 1. Subtract a 1 from both sides, and I have b squared is equal to 24. So then solving for b, I take the square root of both sides. So b is equal to 2 square root of 6. So that's right here. And now I can find what I need for my identity. I can find sine of x. Now I need to be careful because my sine of x is going to be negative here. Even though my cosine's positive in quadrant 4, sine's going to be negative because it's in that 4th quadrant. My y values are negative. So sine of x is equal to negative 2 square root of 6 over 5. And now I can just substitute my values in. So if I look at twice this angle, let's see what's happening. So I have 2 times the sine of x times the cosine of x. 2 times negative 2 rad 6 over 5, that's my sine of x, times 1/5, that's from my cosine of x. Multiply those all together, and I get another negative value, negative 4 rad 6 over 25. And that's my sine of 2 times this original angle. Now let's take a look at cosine of 2x. So cosine of 2x is equal to cosine squared minus sine squared of x. Then I just substitute my values in here. Notice that these squared values are always going to be positive, but it is possible to get a negative value since I'm subtracting. So if my sine value, sine squared value, is greater than my cosine squared value, I'm going to get a negative value. So I have 1/5 squared, that's from my cosine, minus, here's my sine, negative 2 rad 6 over 5 squared. I go ahead and square them. I have 1/25 here, minus, and then when I square this negative, it's going to be a positive, and I square the 2, which becomes a 4. I square the rad 6, and that just becomes a 6. So radical 6 squared is just 6. So I have 4 times 6, which is where I got the 24, over 25. I have to square this denominator too. So I have 1/25 minus 24 25ths. And so then I go ahead and do the subtraction and I get negative 23 25ths. So notice that if I double my angle, cosine is going to be negative. All right. So let's take a look at the half angles now. We doubled our angles. Now what happens if we take that x and we cut it in half and we find the sine and the cosine? So for half angles, you really have to choose that positive or negative. We saw the positive or negative in our formula, and we do that by looking at the original value and then what it would be if it were cut in half. So x is in quadrant 4. So that means x is between 270 degrees and 360 degrees. So that's my angle. But if I cut my angle in half, I cut these in half as well to see what my x over 2 is going to be in between. So here it's between 270 and 360. Here, my x over 2, my new angle that I'm finding, is between 135, half of 270, and 360 in half, which is 180. So x over 2 is somewhere in between here. Now 135 to 180 is in quadrant 2. So if you can imagine the unit circle, 135, between 135 and 180, that's going to be in quadrant 2. So in quadrant 2, cosine of this x over 2 is going to be negative. Quadrant 2 is cosine's negative because we're going to the left. Sine of x over 2 is positive. We're still up above that x-axis. So now we can go ahead and calculate our sine of x over 2 because we know it's going to be positive. So we can choose that positive instead of positive and negative. So when you're choosing the positive and negative sign, you want to look at where your x over 2 values are going to be. And you do that just by cutting the x values in half. So positive, square root of 1 minus cosine of x over 2. Now cosine of x is given right here, it's 1/5. If we were given sine x, we would have to figure out what cosine of x is by drawing that reference triangle like we did when we had the double angle formulas, when we were doing 2 times the amount. So then I just substitute values in here. I know this is positive. 1 minus 1/5. Be really careful if your cosine's negative and you have minus a negative. Just kind of watch those signs. 1 minus 1/5 over 2. So 1 minus 1/5 is just 4/5. So that's 5/5 minus 1/5 is just 4/5 over 2. Now here's where the fractions get a little bit tricky. We have 4/5 divided by 2. 4/5 divided by 2. That's the same as 4/5 times 1/2. This is 2 over 1. I flip that fraction and multiply. I can make a 1 right here, and I have 2 over 5. So as I multiply across, 2/5. So this I just did over here to make it simpler. That's just 2/5. So then I can take the square root of the top and the square root of the bottom. So sine x over 2 is positive rad 2 over rad 5. And if I rationalize the denominator, I multiply both the top and the bottom by rad 5. When I multiply this by rad 5, I just get 5. And when I multiply this by rad 5, I have rad 2 times rad 5 or rad 10. And this is a positive value. So if I were to take that angle, my original angle, and cut it in half, this would be my sine value. This would be my ratio. Okay, so then let's look at cosine. And it's very similar, except for we know cosine is going to be negative here. So we choose that negative sign because of where x over 2 lies. So I have 1 plus cosine of x. And then I am going to head and substitute in my cosine of x there, which is just 1/5. So I have 1 plus 1/5. So 5/5 plus 1/5 over 2. And also always remember to include that 2 under the radical. This whole thing is under the radical. So then I have 6/5 divided by 2. After I add those, I know my square root is still negative. And then I did that over here. 6/5 divided by 2 is the same as 6/5 times 1/2. So this is 2 over 1. Just flip that fraction and multiply. I can make a 1 right here. So 2, factor out a 2 here, and I have a 3 left. So I just have 3/5 when I multiply across. And this is negative. I've got to remember that's negative. That's an easy thing to forget. And I can just rewrite this as rad 3 over rad 5. and this is negative, equals negative, rationalizing the denominator, multiply by rad 5 over rad 5, multiply the denominator by rad 5, and I just get a 5, multiply the numerator by rad 5, and I have rad 3 times rad 5, which is just rad 15. So cosine of x over 2 of that original angle that we had drawn, chopped in half, is going to get me a negative rad 15 over 5. Okay, so let's use this half angle formula to find an exact value of something we don't have on the unit circle. So if you were given cosine of pi over 8, you can't find that on the unit circle and find an exact value. You could type it into your calculator and it could give you an approximate value, but if you want an exact value, we can use the half angle to do that. So we're going to let x over 2 be pi over 8. So that's what we're going to want at the end. We want this cosine of pi over 8, and we're using the half angle. So we're going to let x over 2 be pi over 8. So now I want to know what cosine of x is, because I need that in my formula. So I'm going to go ahead and multiply both sides by 2, and I have x is equal to 2 pi over 8, which just reduces to pi over 4. So my cosine of x equals my cosine of pi over 4. Well, I know the cosine of pi over 4. That's on my unit circle. That's just rad 2 over 2. And I have it rationalized here. If you didn't have it rationalized, it would be 1 over rad 2. So then my cosine angle right here, my cosine x over 2 is equal to positive. And the reason I know it's positive is because pi over 8, my x over 2, is in the first quadrant. So that's before I even get to pi over 4. So I know it's in the first quadrant, so I know this is positive. So I'm taking the positive of that. And then I'm going to substitute my values in. I have pi over 4, because that's what my x is, over 2. Now remember, that gets me pi over 8. I chose that on purpose. Equals positive rad 1 plus the cosine of pi over 4. That's my cosine of x, my original angle before I halved it to get pi over 8. All over 2. So I'm taking the radical of that whole thing. So then reducing this fraction, or simplifying the fraction, I have cosine of pi over 8 equals positive, my radical 1 plus, I know what the cosine of pi over 4 is. It's rad 2 over 2. Substituting that value in, over 2. So then cosine of pi over 8 is equal to, and I am just getting a common denominator. So I changed this 1 to 2 over 2 because I want that denominator to be 2. And then I go ahead and add those fractions together. So I can't add the 2 and the rad 2, so I just leave it as 2 plus rad 2 over 2, and that whole thing is over 2. So this is 2 plus rad 2 over 2 divided by 2. So I did that over here, 2 plus rad 2 over 2 divided by 2, which is the same thing as this times 1/2. So flip the fraction and multiply. And when I multiply, I get a 4 in the denominator and just 2 plus rad 2 in the numerator. So this simplifies over here to this. Then when I take the radical of the top and the radical of the bottom. And this is kind of a weird one because we have a radical in a radical. So I have radical 2 plus rad 2 all over the square root of 4 is 2. I know I'm taking that positive square root because I know this, my half angle, is going to be in the first quadrant.